Okay, so hi everyone. This is Asterix code Karmanya and I'm going to explain the complement of base 10 integer problem. This is the Leetcode daily problem as you have seen the thumbnail. Mm, Wait, let me set up my board first. Oh shit. It's okay. So it's a complement of base 10 integer. So what I have done in this problem is how do you find the complement of an integer? Suppose we have some integers. So I will write everything here because my board is not working. There are some technical issues with this page. So yeah. So suppose we have a integer and we have to find the complement of that integer. So let us suppose that integer is which integer I shall take. Suppose it's 10. So how will you write 10 in the binary form? It will be like 1010, right? 0123, yeah, 0101. This is the binary representation of the integer 10. And how do you find the complement of it? I just flip the digits such that 1 becomes 0, 0 becomes 1. Yeah, so this will be the final integer after complementing, and it will become 5, right? This is the 5, right? So we are given this integer 10 and we have to find the complement of that integer. There are multiple ways to do that in Python. Let me first explain this approach, but this approach is slightly slower. You will get to understand why. So there is an integer n. I have taken a, you can say it is a binary representation, and I have represented by b, and it will be equal to int of I and with XOR with 1. What that means is, suppose these are the integers 1 0 1 0. So I have taken those integers and I have XORed them with 1. So if we XOR 1 with 1, then it will give 0, and if we XOR 1 with 0, then it gives 1. So definitely this will flip the integers. So after doing that, I have done 1. After flipping the digits, it will become 1 0 1 0 1 0 1. So in this way, this b will be storing the individual integers after flipping them. And how will I obtain those integers? I have taken the binary of that number. In Python there is a function which is bin of any integer. Suppose it's 10, so this will return 0x. This is a representation of a binary representation of any number, so it will return 0x and then this string which is 1010. So I have taken this and I have spliced that string starting from integer 2 to the last. So the first two digits have been removed automatically. Okay, so these are from 2 to last. So this statement in itself, this binary of that number is generating the binary representation of the number, and then I have converted it into list, and then after that I have taken the individual digits and then flipped them. After that, what I am doing is I am joining them again by empty spaces in between them. So this is my string 0101. So I am just converting them into 0101. Okay, I'm just joining them together by removing the empty spaces, and then I will return int of n. I will just convert this whole thing into a decimal with base 2. So this second argument which we pass to the int function, it will just, you can say, it just specifies the base in which this number base system or base number system in which this string is represented by. So 0101 is I'm while specifying int of n comma 2, I'm specifying that this is not an integer with the base 10 like in the decimal number system which we use. It is a string with a base 2. So when I specify that, it will automatically convert this thing into the number in the decimal form. So this is one such way. Another way of doing it, what should be another way? I'll just comment them out. So another way of doing that is, what are the other ways of doing it? Let me see if people are watching. Okay, so another way of doing that is, suppose this is given the 10, and what I can do is I just find the, there is one thing you can observe here. If I remove everything, so in order to convert 1010 to 0101, I just have to take 4 ones and subtract this thing from that, right? Subtract this from this thing and it will give me this. Am I right? Am I right? So will that be the thing? Like, I have, if there is, if the length of binary representation of this number is has a length 4, and what I have to do is subtract this whole string from the 4 ones, and I will get 0101 as required. So it's what I can do is I can just take length of, or just I can just easily return that it will be 2 power length of binary representation of the number starting from 2 to the end, because I have 0x at the front, so I have to remove that. So it will be the length of the string. Yeah, so 2 power 0123. Suppose in this case I have to take 1111, and how will I this is the representation of 7, right? No, it's not 7, it's 15. It's 15. So I will now obtain 15, which is, I can just take 16 minus 1, right? So what is this 16? This 16 is the nearest power of 2, which is just greater than the maximum number which I can obtain with the 4 digits of binary representation of the string. What I mean is, if there are 4 ones, then this is directly equal to the 16 minus 1, that is 16, that is 4 zeros minus 1, right? Yeah, it's right. So it's to length of that minus 1. So suppose this was the 4. Yeah, if this was 4, so it is 2 power length minus, no, I don't have to do minus 1. Yeah, it will be 2 power length minus 1. Yeah, 2 power length minus 1, and this will be the number 15, and I just have to subtract the n from that, right? Let me see if this is right or not. Yeah, it's right. Let me submit. Okay, it works. So this is actually 111 minus 1, or there is another way of doing that. There is still another way of doing that. So I just have to find this 16, right? I just have to find the 16. So what I can do is, if I, or not math, I just import everything. So I import everything and I just return the 2 power, what shall it be? Yeah, 2 power int of ceil of log, what is the number, n is the number, to the base 2. So it's 2 power 0 minus n minus 1. Will it work? Yeah, these two are basically the same things. Math domain error. If I take another bracket, why? So it should return the log of 2, right? And let me check in the idle. And what is the value of n? Suppose it's 10. So it's 4. Yeah, it's working fine. Then I don't know. Yeah. So I can do another thing now. Instead of taking the power of 2, I can just right shift 1 with the power that, right? So if I take int of that and I just right shift that by, yeah, it's directly giving 16. So let me explain it first. Why is it negative shift count? What is this negative shift count? Oh shit. Log n log x to the base, right? What do you think? What is the error in that? So int of seal. If I take 4, then it will be, oh shit, the base 2 is 2.0. And what is the log 3 to the base? So I have to take the seal, right? I don't know why is this not working, but you have got the idea. This is the actually the this is the code. So it's when I have to return the to or something, then it might take a little bit more time. So what I can do is I just right shift the one. Right shifting one means one is here. If we right shift it, what the right shifting, how right shifting works is how many steps we have shifted the one, and it will be the number of zeros which will be added in front of it in the binary representation. So if I right shift 1 by 1 digit, so it will now be 1 0, and which is equal to 2. Then again if I right shift again, then it will be what, it will be 4. So when I do right shifting, I am basically taking the powers of 2, and 1 is equal to the 2 power 0, and that is equal to 1. So it's actually 1 to the powers. Okay. Right. So I'm just taking the why is that? Oh, minus 1 here. Yeah, works. Forget that. I think it's not working. It's there's something happening here. I'm not understanding. But this is the main logic. I can just right shift 1 by the length of the binary representation of the number minus 1. And why I am taking minus 1? Because I am taking these 4 ones, right? And I just subtract the number which is given to me, and this will be equal to the answer. I hope you have got it. Just end the stream.